We are starting with the chapter arc and chord properties. Very, very important chapter. Now from the name itself, you can understand arc and chord properties. So you should know the meaning of the word arc and the chord. Then you go for the properties of arc and chord. By this time, what I feel, dear students, you must be very clear with what is an arc. You must have done this. You must have seen what is an arc is. If not so, let's go for a small revision of it. See, I have drawn one circle with center O. Can you see that? I have taken some points on the circumference. Point A, Q and B. Yes, this AB or AQB is nothing but one of the arc of the circle. A portion on the circumference. A part on the circumference. A segment on the circumference. Or a base of the circumference is known as arc of the circle. So AQB is the arc of the circle. Yes. And if I join the point A and B, I get a chord AB. Yes. So arc is converted into what a chord the moment there is a segment joining the point A and B. So now you understood what is an arc and what is a chord. Yes. With the help of this too, the combination of arc and chord properties will give rise to some of the very wonderful properties and the concepts and the theorems. In this chapter, we are going to study about that. We are going to study about the combination of arc and chord properties. We start with the first property. In short, we are studying the first theorem of arc and chord property. I read the first theorem, how it goes about it. The first theorem says, the angle that an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. Yes, we read once again. We revise once again. What is the first theorem? Okay. So what is given to you? The angle that an arc of a circle subtends. Subtends means what? Makes. Makes where? At the center is double. Double of what? That which it subtends at any point on the remaining part of the circle. In short, what I want to say is the angle at the center is twice the angle at the circumference. It's a short meaning of it. We'll take some examples for this. See now the circle in front of you. Yes, see the first part of it. AB is what? An arc. And the angle which is formed with the help of AB is nothing but what? AOB. Yes, angle AOB is formed with the help of an arc AQB. Now this angle, which angle? Angle AOB is nothing but twice the angle. Which angle? Twice the angle APB. This is the concept. Similarly, I have taken one more circle. See the next one. Over here, angle AOB is double the angle APB. The difference is nothing much, but I have taken the angle P on a different side of the circumference. But once again, the concept is same. Because the angle P and angle O are passing from the same arc, that is what AB. But one is on the center and other is on the circumference. So the angle which is on the center is twice the angle at the circumference. See the third circle. See what is given to you. Yes, angle AOB. Can you see that angle AOB? Very good. Is double, is twice the angle APB. In all the three circles, the concept remains what the same. What is that? Central angle is twice the angle at the circumference. Central angle is twice the angle at the circumference. Or what I can say, the theorem which is given to me. The angle that an arc of a circle subtends. Subtends where? At the center is double that which it subtends at any point. When I say any point on the circumference. At any point, okay, on the remaining part of the circle. On the remaining part of the circle. The theorem looks very much easy. We are going to use this theorem in so many sums which are going to do it. Similarly, we pick up the next theorem. The second theorem of this chapter. Now, what it says now. We read this. Angles in the same segment of a circle are always equal. Let's take one example, see what is given to you. Now you see the figure which is given to you. See the figure very carefully. I have given one circle to you. in this circle there are two angles on the circumference. So what is the angle QAR and angle QBR? See these two angles very carefully. Angle QAR and angle QBR. What do you see from here? Both this angle A and B are passing from which arc? Yes, yes, and arc QR. Both the angles A and B are passing from the arc QR. So what do we come to conclusion? Whenever two angles are passing from the same arc and they are on the circumference, their measurements are equal. That was a theorem. Angles subtending from the same arc always what equal in the same circle. And I hope you understood that. Very, very useful thing in doing the sum. Okay, we go for a third theorem of the same chapter. What is the third theorem? What's the third theorem of the same chapter? See the theorem which is given to you. The angle in a semicircle is a right angle. I read once again. The angle in a semicircle is a right angle. Or in other words, what I can say, diameter subtending onto the circumference is always 90 degree. Diameter subtending. Subtending means what? Moving ahead and meeting a point on the circumference is always 90 degree. Yes, see the figure which I am giving to you. We'll make it more clear. See the figure now. In fact, see the circle. So what I have given to you, there is one circle with center O. Can you see that? Yes, very good. Now there is a AB, which is what, a diameter, correct? Now this diameter is moving where? On the circumference at point P, and this point P is where? On the circumference. So what do I come to a conclusion? Therefore angle APB is nothing but 90 degree. Yes, this is the theorem. This is the concept. This is the property that a diameter subtending onto the circumference is 90 degree, or what I can say, the angle in a semicircle is a right angle. Now we move on to the another concept, another property of the same chapter, which says if equal circle or in equal circles, that means in the same circle, if two arcs subtend equal angles at the center, they are equal. In short, if there are two angles from the center equal, they will subtend what? Equal arcs. Equal angle will subtend equal arc. Equal angle will subtend what? Equal arc in the same circle. Yes. In short, equal angles from the center will give rise to equal arcs. Or the converse of this will be what? Equal arcs always subtend what? Equal angles. I revise once again. Equal arc will give a rise to what? Equal angle on the center or on the circumference. What is the figure given to you? For your understanding, there are two circles I given to you. Okay, there is one with the center O, the other with the center what? O dash. There is one arc over there AB. There is an arc what? CD. What I have given you, both the arcs are what? Equal. With the marking AB is what? Equal to what? CD. So definitely, what do you come to conclusion? If two arcs are equal, they will definitely subtend equal angles. In short, if I say the arc AB is equal to what? CD, it will definitely give rise to what? Equal angles, that is angle AOB will be equal to what? Angle CO'D. Or if these two angles are equal, they will give what? Rise to what? Equal arcs. It's a pretty interesting one. I hope you have understood it very well. Similarly, it goes for two chords also. Now you know what are the chords of a circle. Suppose one circle has got two equal chords. So there is one important property which comes. Equal chords will always subtend equal angle, either on the circumference or on the center of the circle. In short, what I want to say, equal chords give rise to what? Equal angles on the center or on the circumference.